One of my favorite songs growing up was Dirt You Made My Lunch by the Banana Slug String Band. Many of you probably haven't heard this song, but I really encourage you that after you watch this video that you'll continue on and listen to their song. And the great thing about them is that they're right. Everything comes from soils. Our food, our clothes, the dyes that color our clothes, and ultimately all the fuels that power our vehicles and our cities. Everything can be traced back to soil. So that brings me to my next topic. While the banana slugs did get a lot of things right, this is not dirt. It's soil. This is dirt. It drives me crazy because I think people use these interchangeably, but there is a difference between soil and dirt. The best way to think about dirt is that it's displaced soil. It used to be soil and it came from soil, but it was moved somewhere that it shouldn't be, like your clothes or your shoes or your carpet. Soils, they're a little bit harder to explain, and so that's what we're going to do right now. One of my favorite quotes about soil is from Hans Jenny, who is the forefather of modern soil science. He said that it is embarrassing not to be able to agree on what soil is. And he's so right because everyone explains soils a little bit differently, and it means different things to different people. To engineers and people involved in construction, they think of something that's moved around by equipment and whether it's suitable for certain construction projects like houses and roads and other big buildings. Geologists think of soil as just a temporary phase in the global rock cycle. It originally came from rocks, and it's soil now, but it will eventually become rock again. Farmers and other people who are involved in agriculture think of soils primarily as a medium for plant growth. It supports roots, it provides nutrients and water, and helps plants grow upright. There's been a lot of debate about soils recently, I think in part due to the recent NASA missions to Mars. Scientists have been discussing whether Mars has soil, or is it Martian soil, or is it fair to even really call it that? My definition is that soils are the mixture of minerals, organic matter, and water that can support life. So according to this definition, do you think Mars has soil? This is a really tricky question, so let's go over it together. The key word here is life. I think under the right circumstances, Mars could support life. I think it's fair to talk about Martian soil, but it's just important to remember that it's different than the soil as on our own planet. The amazing thing about soils is that they're in an interface zone, and what I mean by that is that soils are at the interface of the atmosphere, the lithosphere, the hydrosphere, and the biosphere. Anytime that you're at one of these interface areas, there's an incredible diversity of life. Think about the middle of the atmosphere. How much life is there? Or what about the middle of the lithosphere, or even the middle of the ocean? Amazingly, there is life, there's just not very much of it, and there's not usually very much diversity. However, when you're at an interface area, there's a lot of diversity. I like to think of coral reefs. They're a great example because they are at an interface between the ocean and the atmosphere and land, and there's an incredible amount of diversity. There's lots of other examples like rainforests and even grasslands. So soils are at a permanent interface. No matter where you go, soils are always in between the atmosphere and the lithosphere or the hydrosphere and the biosphere. So naturally, there's a lot of diversity. So we all know that soil comes from rock originally, but how do you get from this to this? The key word is weathering. Weathering basically means the breakdown of rocks into smaller and smaller pieces, and that helps make up soils. Weathering can happen in several different ways, and one of these ways is physical breakdown. Anytime that you have rocks that crash into other rocks or fall down, small pieces will break off and contribute to soil formation. Another big player in weathering is water. Raindrops falling on rocks and other surfaces, and also the movement of water can contribute to soil formation by dislodging small pieces of rock. Think of how the Grand Canyon was formed. It was formed almost entirely from water. All that rock that used to be there is now soil for someone else. Another contributor is temperature. Rocks actually expand and contract depending on the temperature, which can cause small cracks to form. If water gets into these cracks and freezes, it will expand and continue to make those cracks larger and contribute to soil formation by breaking the rocks into smaller pieces. So those are a few examples of how rocks can turn into soil, but there are also other factors that control the rate of soil formation. These are called the 5 factors of soil formation. They're climate, topography, time, parent material, and biology. Differences in these 5 factors can speed up or slow down soil formation. Climate plays the largest role in soil development, and it's also really important to remember that climate is not weather. Weather is what's happening outside right now, like whether it's cold or whether the sun is shining, but climate is the average weather for an area over at least 30 years. This can be seasonal changes in temperature, how much precipitation an area gets, things like wind. They all play a role in how fast or slow soils develop. When you think of arid climates, which are usually very dry and there's not a whole lot of life, soils in those areas take a very long time to form and they're very sensitive. And what soils do form are usually very thin and rocky. In contrast, when you think of other areas that get more precipitation, soil development usually occurs more rapidly and soils are deeper. Another factor that affects soil formation is topography. Soils are usually thinner on mountains and hills and deeper in valleys and depressions. This is usually due to the movement of water which carries soil particles down and into these depression areas. Time is pretty straightforward. Going from rock to fully formed soil can take thousands or millions of years. Which brings me to another important point about taking care of our soils, because if we make soils disappear or we damage our soil in any way, you will not be able to fix that problem in your lifetime or likely in the lifetimes of future generations. Soil is not a renewable resource, so take care of the soils that you have. Parent material is another. Parent material is the rock that the soil originally forms from. This can be rocks like sandstone, limestone, other marine sediments, or even volcanic rocks. These all affect how susceptible certain rocks are to be broken down into smaller pieces because some rocks are harder than other ones. The last factor is biology. If you take a close look at soils, you'll see roots, insects, fungi, bacteria, and so many other things, and they all contribute to soil formation because they break rocks and soils into smaller and smaller pieces. So that's it for this first video. I hope that it gives you a little bit more appreciation for what soils are and how they form and where they come from, and I hope that you'll continue on to my other videos about soils and science. Science is all about asking questions, and I'd love to hear from you and help in your learning experience.